Thank you. Okay, great. Let me see. You made it. So it's been very intensive, very productive. There was really insightful conversations. I learned a lot. But I promise I'm not going to make you more tired. I'll keep it light, being aware that it has been the end of the day. And we are going to close. Maybe if I would ask everyone to get up. Okay, let's breathe in deeply. Breathe out slowly. Once more. Thank you. Well, as the name suggests, it's very boring and complicated, but I'm really going to take it really quite, whoops, if I can go back to, yeah, I'll keep it really simple. So there are a couple of things I'd like to just make sure that what the conversation is about and what are we looking into. There have been lots of conversations about using agent-based models, generative AI, so we are all aware of that. So that's one of the things that the work we are trying to build is based on, the technological component. But there are two other aspects that I'd like to emphasize. Maybe that's also good emphasize in the sense that we are in a complex socio-economic system and environmental system. So when we started this line of work, one of the consideration was in urban spaces, we have trees, we have green spaces, but usually, rarely basically, they are considered as part of fundamental element infrastructure of the system. And the work is, in that sense, many other work in the area is that we need to emphasize that green spaces is also like roads, like electricity, and they provide these benefits. And one way to demonstrate is to be able to quantify. So because our accounting systems, our economic systems, our business models are very short-sighted, they are only things that's being consumed directly, comes onto our accounting models. So attempt was if we could demonstrate benefits of trees or other green spaces, maybe we can take these benefits and turn into maybe dollar values. So hopefully that will go into the budgeting systems. Then municipalities or governments will actually say, we have the values. Planting a tree is not just aesthetical purposes, that it reduces temperature to that degree when there are heat waves comes, or that biodiversity contributes to ecosystem in that level. So that's, and moreover, there are more other ecosystem services, like how much they contribute to mental health. So one step is to raise the awareness, and the next step will be to quantify them. I mean, maybe third step will be to actually convincing stakeholders to actually convert them into their balance sheets and accounting systems. So that was the intention of the work we have started with several partners was, so can we quantify them there, or can we bring the quantifications efforts in one place? And another thing that our component, so this component is about that we need to think of economic modeling. We need to think of that's also part of our budgeting, and just not aesthetical reasons or good to have purposes. And the other thing is, when we think of ecosystems or in built environment, we rarely look into the rights and needs of trees or other life forms. So if we can shift our perspective towards other life forms, where we can understand that they also need to access water when it's really dry, or they also have a right to life. So that's the perspective in that case is what we mean more than human, that we exist in a complex system, and we need to extend our understanding also to animals, plants, maybe other non-life forms. So that's basically the three components that we need to bring together when if we want to change our understanding on the green spaces in an environment. So to start with, we looked into how we can create digital twins of trees, which is easier because they are more visible and it's more understandable. And for that is because they also generate quite visible values. Using the Cynefin framework, so is a complex system framework where if we do some changes or interventions and we probe, we sense it, and that if that goes into creating actions like either financing, adapting our behaviors, adapting our designs, that may create a full cycle. So if we can create cycles of design, probing, sensing, implementation, that I think that's how we can actually create a change. So that's basically the intention, like the work that has been done by many of the participants today is part of that component. So how we can bring them more into the action. And background work, as I guess everyone so much aware of the whole the concept, but how we can actually look into physical context and digital environment. What's the role of simulations? How the simulations can not only give insights to human agency in decision making, but they can also create data that's not available or that's not really clean enough. So if we have good representation of certain models, that may generate synthetic data that can inform the softwares where we develop or tune the parameters. So we need to have a more holistic perspective where we can actually create more healthy, sustainable, long-term connections with environment and the human networks. So that's what we call it Augmented Collective Intelligence, which is basically a tool for communities in their climate actions. Yeah, because I'm not going to go into agent-based modeling. Luckily, I've never been in an environment where there's so many agent-based experts. But one thing just really quickly mention is that even one of the properties of agent-based models within complex systems that it emergence feature, which is when you look into single components, you may not see the whole picture. The great example was one of our speaker was saying, if aliens comes, looks at a human being, they can understand the whole body, but they will not understand the whole society. So we need to understand the interactions. And the same thing in the models we looked into, we were able to see actually the growth cycle of a single tree, which was quite aligned with what has been observed, without actually modeling the growth of a forest. It was amazing to see the life cycle of a forest has a different shape than individual tree cycle, and that we didn't model it, and it was not a question. It was a curiosity to see what if I look into the life cycle of the forest in terms of biomass they create or in terms of the effect they create. So that's also one of the beautiful way of looking into the complex systems, understanding entities and their interactions with the environment, and sometimes you get these insights what was not intended in first place. So the work we have done is actually now we have a platform. I will be able to show, which is basically you can go if you have 3 data sets. We have worked with several cities, and if they have the inventory, send it with location-specific data sets, and they can actually we use the data sets which are basically if they have the species location information, the height of tree, if they have also the size of the tree, then we create agents basically and place them on the space, and then looking into interaction between them, the climate they are inside, and also the maintenance activities the tree officers or municipality would like to do, and see that they grow over the years. And as they grow, we calculate how much carbon they keep. This is not so important in the city environment, but how much cooling they would provide if there's a heat wave. If there's an extreme rain event, how much water they delay. So they may actually reduce the charge on the sewage system. So then they can always observe the impact of existing trees, or given an area, we'll say, if we combine these compositions of trees with the and with that size, how they would grow and what would the impact. So this is available. The model itself is open source. We also have the paper describing the basics on the model. But what the next thing was, as I have said, the third component is we need to change our relationships with nature. And it's one way to change the relationship, like maybe humanizing them, unfortunately. And one of so we have run several joint research projects with several master's students and PhD students. So intention was taking the framework we built. The framework we built was basically to be able to add any other life forms in an urban or non-urban forest. So design interactions. So then we can see how that ecosystem grows. So this is basically a typical ecological model. And luckily, the researchers that worked with us, they wanted to have more conversational understanding of, like I had conversation with the trees. So this is maybe very romantic or hippie, but in a way, it may change our perspective. So several works have been done. So it's not very reasonable, but in this case, they did a test model with LLM. So the tree was basically creating poems. But this is beautiful, but we need to go a bit further than having poems. And one of the research projects was quite interesting. It was in Amsterdam. There was a very dense city forest, Vlieggenbos. And the interesting thing with that city forest, there was a discussions about what can be done. So there are different kinds of stakeholders. There were a sports court. They want to extend the tennis court in one group, and the community, the neighborhood, in the neighborhood, they want to have bike lanes, which means having light posts. And there was also a factory. Our researcher, undergoing and talking to the stakeholders, she also came up with a knowledge that there's actually a very unique glowing worm only exists in that forest because it's the densest forest in the city, and it's the only way they can survive. If you end up having bike lanes or extend, so that will not be able to live further. So what she did with the research, taking the framework, putting the needs of the glowing worm, and saying, if we extend the pathways this way, what will be life form? So this is like very straightforward. You can understand that, but this is in a way to see that we need to think of other life forms, especially in our joint environment. Lastly, so luckily, a couple of weeks back, we kicked off a new project, which is building together what we have done all together to be able to actually create a conversation with a tree or any plant green space, but not just sending love letters back and forth. This is very, very simple version. The team is using gathering data in certain area within Coast Amsterdam, which is looking into the trees that are living out there, and connecting all the data together with one of the open source, we are trying several open source large language models. So, but imagine you have an application, hopefully in a few months we will have the prototype. You have an application, you go out, you took the camera towards a tree, and this application that's on the back end is already working, connects the all data sets we have, and then also determines the species of that tree. With the imaging, we understand the height and all the variables with the tree, and it creates a profile. Maybe with the actual picture, not the AI-generated picture. In this case, because this was on the background, did you see the location, the trunk size, and the height of the tree? And then the intention is once we have this, so it may be on your background, or a street that you always walk, then you may end up having more actually context, place-dependent interaction. And intention is to be able to see how we can maintain better, or to understand what kind of other biodiversity things are happening around. The tree itself provides quite a large space for other life forms, and also to extend the knowledge, general knowledge about that. So that's changing the awareness of it. So this now we are also working with small municipality that will possibly use in a prototyping with municipality in their scheduling. The AI will be able to give schedule saying this time of the year you should need to take these branches off, or you need to, last 2 weeks there has been no rain, and very likely based on that sensor, I may need a bit of water. So in a way, having on the place easy access to what kind of knowledge we have, how we can interact with a kind of non-human entity. So that's the work going on. Hopefully in a couple of months we will be able to use a mobile application. So that's well, that's it. So as I promised, I kept it short.